Hello there. All right, man, can you believe the semester's almost over? Blink of an eye, blink of an eye. All right, let's get into this. So, we are looking at Newton's law of heating and cooling. And for questions like this, we typically give you the equation. You do not have to memorize all of those working parts. So if you encounter this in WebAssign or the textbook or wherever, feel free to use the top of the note page to remember what all of those different letters are, like that. But typically we give you the equation, and like you see from the questions, we're asking you what some of the parts are, like that. But creating it from scratch, like the other examples, you do not have to do that with Newton's law. All right, so what's the y-intercept? Plug a 0 into the equation, and there you go. What's it mean? Always write intercepts as points. Way back in Unit 2, I started saying that in the very first lesson. So what does it mean? Well, the input is when the chicken was first placed in the oven. The output is the temperature of the chicken. There you go. And I could have said internal temperature. Um, anyways, the next one is the horizontal asymptote. So we learned that at the beginning of this unit, the basic structure and that goes back to the transformations earlier in the semester. So this is the up or down vertical shift, which is the number you add outside of the x. Hence 350. You see where it is in the equation there. And remember, all of the interprets explain the input, explain the output. So the input is as x increases, as the input increases, as the time cooking the chicken increases, like that. So specifically, you put it in the oven. So after we first put it in the oven, the temperature of the chicken is, you see what I wrote right there. Some students might use like the phrase levels out at to 350. Not technically max because mathematically we never reach the horizontal asymptote. Now, if you've ever cooked something and you have a thermometer, the thermometer just says 350. It doesn't say 349 point a billion nines like that. All righty. Next question here. We've got our kind of obligatory plug a number in and set equal to. So this one is cooking after a couple of hours. So make sure you change the units. If you plugged a 2 in there, you should get a weird number. That's really, the temperature is still pretty gosh darn cold after 2 hours. So put a 2 in there is 2 minutes. So you got to change it to the right units, use 120 there. Plug it in, calculator, there you go. Remember the units. The next one is solving. So we're asking for the time it takes to reach this temperature. So you set it equal to, and like the earlier lesson, solve the exponential. So isolate the exponential and then apply whichever one of the techniques that I gave you. I gave you several techniques in solving exponential equations, whichever works for you. I like using the definition of the logarithmic function, the geometric shape switcheroo thing that I gave you a while back, triangle, square, circle, like that. Finally, divide by the coefficient, type it in your calculator. This is one of those things where I always caution you about rounding too many times. So maybe you rounded the fraction and then you plugged it into the natural log and rounded it, and then you divided it by that, and then you rounded that. It might be too much and your answer's wrong. So I wait until the very end and then I type it in my calculator all at once. So practice with your calculator, figure it out. Unless you experiment, you don't know whether it will or won't be off. And while my notes normally don't have specific rounding instructions, it's good to be accurate, 2 or 3 decimal places, but always follow the rounding instructions, but don't round every single step. Awesome. All righty. I'll see you. Looks like we got another video. See you later. Oh, there's the answer. I forgot to give you the answer. Squiggly line approximate